Yeah, welcome to my session. Let's continue our preparation certification for the Databricks Spark developer certification. Let's continue that. So we have completed three modules. In the last module we are at. So let's go through the last module, and all the links are already given in the description, so you guys can just go ahead and see. So let's continue. One second. So these are here. It is optimizing Spark, and these are the individual sessions we need to start. Okay, let's continue. Mm, Third slide. Okay. So the background is database background. So a unified data and AI platform built by the creators of this Apache Spark, founded in 2013 by creators of Apache Spark and Databricks. Um, in is built in open source foundation, Apache Spark, Data Lake, and MLflow. Uh, is available on all major cloud platforms. So pioneered the data lake house and medallion architecture. Databricks features enterprise grade security and governance, collaborative notebooks, and workspace environments, optimized performance through prop proprietary enhancements. There are a few enhancements done, and it supports multiple cloud platforms, and it has ML flow as well, machine learning flow as well, and all the other important key features are available in the Databricks environment. Let's think about the lakehouse perspective. So, what are all the features that it has? So, let's read out those things. So, unified architecture combining data and warehouse is called lakehouse. So, the structure of data warehouse with the one second, let me see. Okay, yeah, yeah. So the structure of data warehouse with the extensibility of data lake, scalability via separation of storage and compute. It has different features. Support for all data types, structured, unstructured, semi-structured, all type of data types it will support. A unified batch and stream processing support, and built-in security and governance. A background on data warehouse and data lake. A data warehouse is designed for structured data, optimized for BI and analysis, and the strong schema enforcement and governance, but can be costly and flexible. But data lake is like, store raw adverse data types like structured, semi-structured, and structured, offer low cost storage and flexibility, built often but often lacks performance, governance, and data management capabilities. Lakehouse is like, the architecture bring together best of both worlds, like structured schema and traditional capabilities of warehouse, and flexibility and scalability of data lake. So these are all the main combinations have using for this. And the medallion architecture, you already know, layered approach to the data, raw data, from there to bronze, and to silver and to gold. So what happens in the bronze layer is, whatever the raw data you stored, and with the history copy to the data lake. So source copy with history is the bronze layer, and cleaned and confirmed, but not aggregated data. Clean data, cleansed data is in the silver layer, and gold layer is business level featured aggregated layer. Features and aggregated layer is the bronze layer. Okay, for example, the medallion architecture is a layer design used within the lakehouse for managing data quality and transformations. It builds on the lakehouse, not replacing it. Just a layer, same like Spark. Spark, Databricks build on top of Sparks, but it won't replace it. Not replacing it. There are three layers. Bronze is raw data layer, sorting data exactly as it arrives for storing data exactly as it arrives for full traceability. And silver is the where data is cleaned and deduplicated and enriched, but without changing its level of detail. means no aggregations are done here. Gold is a business layer where aggregations, KPIs, key performance indexes, and features and business logic are applied, making um, data ready for reporting and analytics. This approach helps keep data organized, clear, and reliable at its moves from raw ingestion to final business use, while still keeping the flexibility of the lakehouse. So Databricks workspace, you can create different workspaces. From that, in the Databricks account, you create an account and create a workspace. Each workspace for the different purpose. And isolated collaborative environment for organizations, departments, teams, objects or analytics included. Compute resources like Spark cluster and a serverless warehouse. Yeah, it's serverless. Directories and notebooks. So notebook is a piece of code and it organized for the better organization. There are directories, jobs, Delta live table pipelines and workflow jobs. Delta live table pipelines and workflow jobs. Access to objects in Unity catalog like tables, views, functions, more models, and reusability of all those things will be there in the Unity catalog. You'll store everything. I'll try to store these type of reusable metadata. I can say. Uh, and simplified governance and security access control, of course. Purpose. Okay. Databricks runtime. What is Databricks runtime? Is a DBR per packaged and tested combination of Spark core and peripheral components. Some predefined components are there, and simplified operations and boosts performance. So those are the runtime type includes like a standard runtime. Mm, it's like machine learning runtime and photon enabled runtime. This is important to understand. Like standard runtime is base Apache Spark with Databricks optimizations, pre-configured with popular ML libraries. These are some popular ML libraries are pre-configured in the machine learning runtime, and a photon enabled native vectorized engine for SQL performance. So to enrich the SQL performance, vectorized like it's like a cube type of thing. It will be enabled with the photon enabled runtime. Compute option, all-purpose cluster, job cluster, SQL warehouse, and the serverless computes. That's we already know. All-purpose is like interactive development and analytics, support for most underlying cloud provider instance types and sizes. Okay, this is job cluster is automated production workloads. You schedule everything and everything will be orchestrated through this job cluster. SQL warehouse and serverless compute, no cluster management. You need not to worry about it. It's like an on-demand instance, so that in it can lambda type of a thing, so it can be triggered. Okay, additional notes like mentioned variably if time permits, supports instant pools for faster cluster startup and resources reuse, supports instant pools, faster cluster startup and resource usage. Spot instances can be used to reduce costs on uh, ephemeral workloads. I'm not sure about this. Unified data governance and security across your Databricks lakehouse. Just a minute. Yeah, I'm back. Unity catalog manages data and AI assets across workspace. It's like a common pool for most of the governance areas, like simplifies security and governance and provides data discovery and sharing. It's like it keeps the lineage, shareability, and sharing with other workspaces and all those other stuff that Unity Catalog helps. Um, a control plane is the centralized system responsible for managing and orchestrating configurations and policies. In this context, Unity Catalog acts as a single control plane for managing data permissions like table, column, row level access, all the other stuff. It's like an access management thing, and handling lineage, auditing, and compliances, sharing data assets across multiple workspaces. This is the best we can see. Next session is like Apache Spark and Databricks collaborations are informed here, and now this is using Apache Spark with Delta Lake. So that is retake this session. Let me see. So it's live. Okay. So introduction to tabular storage evaluates of open table formats for cloud data lakes. Traditional data lake challenges: no transactional guarantee, no schema enforcement, performance issues with many small files, no built-in data quality controls, default metadata management. So these are the regular data lake challenges, and the storage evaluation of storage formats like basic data representation, JSON, CSV, Parquet, ORC, and data. Apache Iceberg is some type of data format. It seems tabular transactional storage. It's Delta Lake and Apache Iceberg. Early data lake used raw file formats like JSON, CSV on storage like HDFS or S3 with no transactional guarantees. Schema enforcement or proper metadata management makes data unreliable and hard to catalog. Yeah, of course, that is correct. Small files also hurt performance. That's correct. Columnar formats like Parquet and ORC brought better comparison and faster reads, but still lacked transactional support. That's correct. Modern formats like Delta Lake and Apache Iceberg now add asset transactions, schema checks, and time travel features to data lake, making data reliable and consistent and easy to manage. This is the next level feature it is introduced, and in the now we coming with the Delta Lake. So in the Delta Lake aspect. So introduction to the data lake here is an open format bringing asset transactions to the data lake. The data lake plus asset transactions is called Delta Lake. Now, what is Delta Lake? Open source storage framework. It's a storage framework created by Databricks, built on top of Parquet. Brings reliability to data lakes. Native ingestion with Apache Spark. Okay. Data Delta Lake features easy transactions at scale, schema enforcement, schema evolution, time travel, means versioning of the data will be there. Unified batch and streaming, scalable metadata handling, unified batch and streaming. Okay. Why Delta Lake? Eliminates data inconsistency, enforce data quality, concurrent reads and writes. Okay. Simplifies data pipelines, reduce data lake management complexity. So since the Databricks internally handles this Delta Lake, that's the best way. Delta Lake is an open source storage format from Databricks that open source it is also, and that brings ACID transactions to data lakes built on Parquet. It allows fine-grained data updates. Of course, the same information they have given. Next is like how Delta Lake works. Understanding the transaction log and versioning. Each insert, update, delete operation computes a delta from the current version as files added or removed. Okay. Create new delta files if necessary. Commits a new version to the delta log. So delta log maintains everything like version 0, JSON includes data file A and includes data file B. A and B together, it is another version 1 here it is. So the versionings will be there in the delta log. So it will keep a good tracking of all those stuff. Okay. Each select operation gets the main manifest of data files from the version in the delta log, latest by default of course. Returns the data from amalgam of files in the versions. Okay, versioning, the better versioning is maintaining in the delta log, that is the better feature here. Okay, delta log tracks changes through a underscore delta log folder in each table's directory. It's a table directory. Okay, delta lake dictionary here, and table X is the table name, and it has all the other features, and file A packet, file B packet is there, and it's added to this, and yeah, of course that's a very good thing. Creates the last version less the current files that make up the table. So delta lake always reads the right data. This log acts like a manifest, enabling fast updates, time travel. Time travel means going back to the previous version, and reliable data consistency without rewriting all data. That's a very good thing. Next. So Delta Lake operations, advanced operations enabled by Delta Lake's transaction log. File generated, delete and update. File fine-grained delete and update operations. Raw level modification includes condition based operations. Merge, true upserts, update plus insert. Upserts can do delete as well. Okay, merge will help to do that. Support for complex merge conditions. Schema evaluation includes create or replace table operation. Okay. Time travel, ability to ability to read the previous version of the data. That's good. The Delta Lake transaction log allows you to make low row level updates and deletes without rewriting the full dataset. You can use merge operations, absurd, to insert, update, or delete based on the condition. Schema evaluation is supported. Create or replace table. Okay. Updates the schema, and you can still access either schemas through previous versions. The logs also enables time travel, letting you view or restore data. Of course, time travel will help you to based on the timestamp. Okay, now I got it. So let's see an example for that. Apache Spark and Data Lake, how it works. It will directly store Delta as a format as Delta, and mode is so and so, and table path it will give append mode and the other formats. Integration between Databricks, Spark, and Apache Spark and Delta Lake. Okay, read from Delta Lake tables. So read format Delta, load so and so path. Write two Delta Lake tables. Delta mode is append. Okay. Delta Lake is the default for Databricks. If you don't specify the format, default read table path. If it reads table path here directly, and it will be read from the Databricks. df.write.mode append.save, it will directly write to Delta. Format Delta is the default. Okay. Delta specific Spark SQL commands for inspection. Describe history, describe detail. Maintain and maintain performance commands like optimize and vacuum. Optimize, I think, okay, optimize will help you. I think it's here. Okay. Maintenance operations like optimize and vacuum help manage file sizes and storage, improving performance and keeping tables tidy. These commands will build directly into Databricks experience, further simplifying Delta Lake management and takes and making it as a smooth part of every workflow. Okay, that's fine. Performance and maintenance, optimizing and maintaining Delta tables for production workloads. Table optimizations, like you can optimize the table z order by date. So the order it will maintain in with the help of z order. Log cleaning operations, like for example, skill vacuum last 168 hours. This vacuum command will remove all the files before 168 hours. Okay, more than 168 hours old, then it will be removed. Best practice, like use table partitioning for large eventful datasets. Monitor file sizes. Watch for excessive small files. Okay. Auto optimize and auto compact enabled by default on Databricks. So the example to mention in demo: alter table by table, set table properties. Delta auto optimize is true. Optimize, right? Optimize compact. Auto optimize and optimize compact is true. This config ensures that files are written and compared effectively without needed to run optimize manually. It's automatically if you specify anything here. Okay, right. Apache Iceberg. Okay, an alternative open table format for cloud data lakes. What is Apache? Open table format created by Netflix. Okay, similar goals to data lake, asset transaction, schema evaluation, hidden partitioning. Okay, hidden partitioning and partition evaluation, branch and tag support. Okay, Spark integration, format iceberg. You need to mention load to the corresponding table and write to. Hidden partitioning. Unlike traditional partitioning where partition columns are visible in the data, Iceberg abstract partition details from users. Partition transforms happen behind the scene. Okay. Users query natural columns. Iceberg handles partition pruning automatically. Can change partition schema without change queries. Okay. So one more thing is partition evaluation. Can change how to table is partition without rewriting data. Old and new partition schema can coexist. Okay. Queries automatically use most efficient partition schemas. Enable. Okay, it's all talking about the partition levels and some more. Branch stack support, like similar to Git branching concept. Okay, so prod dev. This is all about Iceberg. So let's stop here. I believe video and optimizing Apache Spark. This is pretty important. So let's continue this. This is the important lesson. So the optimization, we have around some percentage of marks for this. So let's retake this lesson. This is important. Right. So just a minute. Okay, understanding Spark for performance, knowing where and why your Spark applications spend their time. Okay, now key factors attending performance, resource utilization, and data characteristics. Of course, what type of format it is, and size, distribution. Of course, configuration, starting configuration settings, and cluster setup. IO, task scheduling, and compute operations data movement. These are understand where time is spent in Spark job. Common bottlenecks, data skew, and uneven or inadequate partitioning, excessive shuffling and data movement, memory pressure. These topics we were discussing in the our Spark class actually. So memory pressure and the garbage collection. These are the main aspects you need to worry. To tune Spark effectively, it's important to first understand where your Spark jobs spend most of their time. So you can identify bottlenecks that slow down performance. Okay? Key factors influencing Spark job efficiency are resource utilization usually, like your job is how much CPU utilizing, memory, which type of memory, network is perfect or not, and disk IO it is writing how many files it is writing to disk IO. That's the main key aspects. Mm, Data characteristics such as size, format, distribution, and coordinate and skew, of course, and the configuration and sizing of your cluster. Obviously, it's very small cluster, then your performance will be like uh, very tough to complete. And common bottlenecks in Spark applications include data skew, uneven distribution of data, poor partitioning, too much shuffle during data movement, and memory pressures resulting in heavy garbage collection. These performance issues can directly affect resource usage, as it's crucial to granularly review and adjust regularly review and adjust cluster size, partitioning, configuration settings, and much more. So next slide. Main aspect is partitioning. Data frame partitioning determines data distribution. Partitions are determined by for a files or blocks when data is read from a table or directory. Initial memory partition. That is known as it's an initial memory partition, and also result of a wide transformations. Okay, this is offered as a shuffle partitions, and default partitions of Apache Spark is hash partitioner. Okay, number of partitions. This is the default partitioning. Okay, importance of data distribution. Just give me a break. 2 minutes, please. Yeah, let's learn what happened internally in the partition aspects, like initial partitions. When Apache Spark reads a file, it creates partitions based on underlying file splits. Maybe the block size, file size depends on that. It'll partition. Initial memory partition. There are initial memory partitions. They are defined before any transformations, of course. The driver decides the number based on Apache Spark configuration like max partition bytes and dispute default parallelism. Based on that, I think now it is 512 MB. I'm not sure now, but yeah, shuffle partitions. Let's see, max partition bytes. Max partition bytes in Spark. 128 MB was there, but I don't know now. It is still 128 MB. Default is 128 MB. You can tell how much we can extend. Yeah, 128 MB. Hmm. Yeah, got it. So yeah, default parallelism. Okay, shuffle partition create during wide transformations, of course. Shuffle partition number default is 200. I mean, we can increase that, depends on the situation. Um, these affect how data distributed across the cluster during a shuffle stage. These partitions are often much smaller and can drastically impact performance if not tuned properly. Of course, it is. Next, choosing partition keys. Repartition coalesce. Okay. So repartition, you wanna specify to a number of partitions. It will go just with repartition. And if you wanna decrease the partition without shuffle, then go with coalesce. That's what I said in the earlier session as well. Choosing partition key, automatically repartitions on group by keys, of course. DF repartition n comma column your column name to repartition on another key. If you want to repartition on another key, you can just do it in that way. um, n means number of partitions here. 10 comma column, partition column you need to mention, column of column name. Right sized several partitions, target 100 MB 200 MB per partition. Partition should not be less than number of cores. Okay, if number of cores available, if you do less partitions, and there will be some cores that are idle without any work assigned to it, so that is the problem. That's why it says partition should not be less than number of cores. Okay, df repartition of n or df queries n. Monitor task duration am 50 to 200 milliseconds. Okay, maybe it's okay. Next, shuffle operations. Okay, understanding and optimizing Apache Spark's most expensive operation. mm, Recall that shuffles are triggered by wide transformation or changes to partition counts. Network IO required by shuffles impacts job performance. So when you exclusively want to repartition or any wide transformation, it involves shuffling. Shuffling need IO, network IO and disk IO. Okay. How to minimize shuffle impact? Filter early filter often, use broadcast join for smaller tables, configure shuffle partition based on data size. Okay, maintain consistent partitioning where possible. So monitor shuffle spill matrix, memory versus disk. So this is the same explained in this. Now let's see, Spark will help in this. Okay, caching is one of the important concept in this. When to use caching? Multiple access to same data frame, like you have a costly join operation, but the same join operation, whatever the data set created by the join operation, you want to use it in future, try to cache it instead of re-executing the join again. That is the best way. Expensive transformations are upstream, of course. um, Interactive analysis and ml iterations. Okay, lookup tables used across operations. So these are the main areas. There are two methods: caching management, with to use df.cache or df.persist explicitly, monitor executor memory usage with UI. Okay, call df unpersist when no longer needed. Once it is done, once the operations performance, once you do the required operation, then you need to unpersist. Okay, caching is used to keep intermediate results in memory, which speeds up iterative or interactive Spark workloads. You only see a benefit if you refer to the same data frame multiple times in the same application instead of recomputing the data frame each time. Spark can quickly access it from memory, making repeated operations much faster. Yeah. The trade-off is that caching uses up executor memory. That's the problem. So it's best for data frames you reuse often. Only it's reused, then you do caching. You can cache data frame with dataframe.cache or dataframe persist. When you no longer needed it, you call unpersist to free up memory. This approach is helpful when same data frame is accessed several times in your job. Okay, so try to keep in your program at the last the unpersist thing as well, which data frame you need to unpersist. Okay. Joint performance considerations. This is pretty important. We need to understand. Broadcast, of course, we I already explained in this in my Spark session. When data set is little small, you try to do broadcast that particular small data frame into all the things. So that's why you can avoid it. This is the caching mechanism. More joint performance considerations are skew, uh, data skew handling. See, sometimes both data frames are huge. In that, there is data skew due to uneven distribution of join keys can impact performance. Consider repartitioning in some cases. Okay, memory management. Monitor shuffle spill matrix for joins. Consider caching frequently joined data frames. Use projection to select only needed columns before, yeah, of course, joining. Okay, query optimization is all about adaptive query execution is the important concept we need to learn. Okay, catalyst optimizer. What it will do? Logical planning, in the logical plan to physical plan, unsolved logical plan to physical plan, it will be happened by the catalyst optimizer. uh, okay, and use df.explain. df.explain extended. See the logical and physical plans to compute a data frame. So you want to see that plan, you need to do df.explain the data frame explanation. We can see next predicate pushdown. Predicate pushdown means automatically filters and column selection to database sources. Like for example, if you mention somewhere the filter option at the bottom, but still it will come up and filter first, because with filtering the data will be less and it will be very useful. That's called pruning. Okay, that pruning predicate push down means based on the necessity of that particular operation, it will move up and down of a particular operation in the operation or transformation in the Spark. That is predicate pruning. Adaptive query execution enabled by default automatically optimized query plans at runtime using real statistics. So it's an inbuilt functionality of this environment that enables by default automatically optimized query plans at runtime. Okay. So let's read out still it is a very since it is a very important concept. When you submit a query to or action in Spark, Spark Catalyst Optimizer automatically plans and optimizes your query. The process starts with an unsolved logical plan, then move to an analyzed logical plan, unsolved logical plan, analyzed logical plan, optimized logical plan, and finally a physical plan. Okay. At the at the last stage, Spark generates code to execute across the cluster's executors. You can view these plans using DataFrame.explain. Okay. Which shows how Spark will execute your query. A helpful tool for debugging and optimizing. Predicate pushdown is another key feature. When you filter data from an existing external source, Spark pushes those filters down to the source database. Pushes down those filters to the source database. This means only the needed rows are pulled, reducing data transfer and making queries faster. Spark also uses adaptive query execution by default, which means it can adjust execution plan at runtime based on the actual data, further improving the performance and efficiency. All these optimizations happen automatically, helping queries run faster and use resources better. Okay, so the best practices is related to Spark UI, and the other stuff, general tips. Use of Spark UI, track job progress, stages, and task metrics, monitor shuffle, storage, and executor details. Everything in the Spark UI will be visible so that you can see. Filter early, often, filter often. So filter any filter thing is happening, you just do it immediately and minimize the use of UDFs. Don't use UDF. Use Pandas UDF as previously discussed if there is any need. Optimize partitioning and tune shuffle invoking operations. Optimize joins are is very important. Detect and avoid data skew. Minimize UDF use. Apache Spark, why we need to minimize is like um, mm, Catalyst, it needs to perform some on top of it will get some overhead out of it. So for the UDF hierarchy, SQL built-in functions, Scala type UDFs, Panda vectorized UDF. If that is not done, then only use UDFs when there is no built-in alternative. Otherwise, it will give a overhead to the serialization overhead. So this is the end of our session, I believe. Let's see if there is any further thing need to be done here in this. 1 minute, sorry, I forgot. I accidentally closed it. 1 second. Mm, mm, Okay, so there is a demo, I think, of optimizing Spark, and after that, it is a demo, and that's it. Yeah. This is the end of the session. I think let's connect in the next session. I'll try to write an exam in front of you. Let's see how it goes. Okay. Thanks for the session and thank you. Please subscribe.